Sorted?
Sorted? Yeah, just that's me.
Hi, David.
Hi, David. Hi, Prakash. How are you doing?
Good.
Good. Who's doing CRUST? Is it you and
And Niall,
Niall? All right, aye, that's right, Niall. Excellent.
I don't know if Niall is there.
No, he's away.
Okay.
Okay. He's away somewhere else. But yeah, we'll just go over it. He can get the recording. So CRUST is a really good library actually, and it does a lot for us. In the last sort of thing we were talking about routing and routing's relationship with CRUST, and I was kind of making it clear to people, CRUST is an IP layer thing. It knows nothing about anything above it. It knows nothing about routing IDs, it knows nothing about what we're trying to do with it or anything like that. So CRUST is an IP based solution, and the idea with CRUST is it's for peer-to-peer networks. And that means if there's a peer-to-peer network somewhere and all of them have got their own addressing and routing mechanism, all peer-to-peer networks have that. So CRUST sits underneath it. And gives it the ability to communicate. So the nice thing about CRUST, where we want to see CRUST is basically that we've got some kind of network here, and CRUST is sitting here and just connects to that network. So it says I'm connected to the network. And importantly, it's just connected to anybody. It doesn't care who it's connected to. It just says I'm connected to the network. I'm probably connected to people that you don't really want to be connected to, and you're going to ask me to drop these connections and create new ones, but my job has been to connect you back to the network. So at the very bottom layer, at the IP layer, CRUST has said, okay, you're connected. Now what do you want to do? And for us to be able to use CRUST, we need to know some kind of way to start it. And for it to tell us, here's their connections. So we just need to know what connections have you got. You get like some TCP thing and maybe some UTP thing and maybe some other stuff, maybe some pipes and whatnot. So we just need to know we're connected to the network. And for us to have a connect where we want to connect to some person with a proto and an address, and then we want to know if we've lost a connection, and we want to know if we've got a connection. We're really not wanting much more from CRUST than that. And what we don't want to do above the CRUST layer, the things that we don't want is we don't want to know anything about bootstrap information. We don't want to know anything about NAT, traversal or otherwise. We don't want to know any of that sort of stuff. So CRUST is basically saying, don't you worry about all these things in red. I've got them covered. I'm going to do all that for you. So all you need to know is I can get back in the network. I can tell you you're connected to a couple of guys. It's up to you to chat to them and do some other stuff. And you can connect to other people. Obviously send messages, drop connection and things like that as well. But CRUST just basically saying to us, we'll take the headache of all the NAT stuff, all the bootstrapping stuff, all the connecting to where you were off your hands. And that's really what we want CRUST to do. Now how it does that is, well, just over to you, Prakash, that's how but how it does it is it's obviously going to have to keep a bootstrap file. We've got so that we can connect remotely. So we can connect to some guys remote. We've got a beacon. So we can connect on LAN, connect LAN or local PC. So these are the ways that we kind of want to be able to connect back to the network. And we have to consider that there might be no beacon. There might be nobody in the PC. There might be nobody in the LAN. So the beacon might fail. And we must bootstrap then. We must try and bootstrap, or we are node 1. So just looking at CRUST from its very foundation, we're saying to CRUST, if there's a network, you must connect to it. You must connect to that network. So when CRUST first starts, this is going to be empty. There'll be no bootstrap file and nothing for it to connect to. So the very first network on a peer-to-peer network, from CRUST perspective, let's call it CRUST 1. It's going to have no bootstrap file. It's one of the nodes that we've started, that we have to connect to. And we might have several of those. And maybe these are what we have as hard-coded nodes. So these are hard-coded nodes. And what that means is these nodes, for users of the CRUST library, should pass at least these nodes through to the bootstrap file of CRUST. So if you've got some hard-coded nodes, so these are also nodes, that means we have to be able to pass to CRUST fixed listening ports, so that if those things restart, that they restart on the same port that we originally had them on. And that's okay, that's pretty straightforward. So we need the ability to have some hard-coded nodes and to be able to pass these hard-coded nodes either through the CRUST API or install CRUST with a bootstrap file that's got those hard-coded nodes in it. If the hard-coded nodes are in the bootstrap file, we should identify them as hard-coded because of the way the bootstrap file should work. So the bootstrap file itself should work like this. If CRUST connection is direct, and I'll say direct, we should come up with a word for direct, but if we can get to that connection via more than one CRUST node, then we consider it direct. then put in Bootstrap. Then limit Bootstrap to 1500 newest nodes. Right, so we always want to have the newest nodes, and that is why we need to identify hard-coded ones as different. We either pass the hard-coded ones through every time through the CRUST API, or we identify them in this Bootstrap file as something different, i.e. they don't need to be the newest nodes there. I'm just going to try and block this sun a wee bit. So the Bootstrap file is really important. The ability to hard code or pass through fixed listening ports to nodes is really important for these guys here. Not only these guys, there's another situation where you want to be able to pass the listening port through, and that's where people have port forwarded on the router. So if you've got TCP or UDP, doesn't matter, you can always port forward on your router. So if you've got TCP or UDP on your router, you can say port X should go to IP port, and IP being a local IP on the network. So you might say port 8080 always goes to 192.168.0.1 80, just 80, and that could be TCP or UDP, doesn't matter. So in that case as well, you want to be able to pass a fixed listening port, because after you've port forwarded something, you don't want to then change IP address here, because you'd have to get into your router and change the table again. So these hard-coded endpoints are not only the only reason to be able to pass through the listening port to CRUST. So that's pretty important. And just getting that right means that CRUST should always be able to connect back to the network it's supposed to connect to, unless there's a dramatic thing like you physically aren't connected to the internet, the router's off or something like that. So that gives us an ability to connect back to the network we were on, which is pretty important. The beacon gives us the ability to quickly create test networks, and if we're using our local machine or local network, it gives us the ability to test all this stuff really, really easily just by switching the thing on, not doing anything else. So in terms of protocol handling, we've got TCP and we've got UDP. So we need to make it connection oriented. TCP is okay, and we switch to UDP for that. Then we need to have that traversal. So that traversal, what we do here is hole punching, and that's where we use a rendezvous connection, or just a connection with a longer timeout than usual. That traversal with TCP, we've got UP and P. And for UP and P, you can actually take the Rust BitTorrent library, and it's got a UP and P file, and we can just put it straight into our thing. We've got NAT P&P, which I think is died. I think NAT P&P's died. That was the Apple thing. And we've also got hole punching. And that's, see the paper. There's a paper on the README of the library that explains hole punching. And then we've got NAT detection. We should probably call NAT detection something like bootstrappable. Some kind of bootstrappable thing. And both of these will use the same mechanism. So basically, if A connects to B using whatever it did, on here both of these also have port forwarding. So if A connects to B, then A should ask C also connect to B equals OK. We can bootstrap. And the same process here. Now, there's a slight thing that, I'll just take that line away just so that it is the same. If B address is local, then bootstrap is okay. So if it's a local address, you can connect to them anyway. You're not through a router. By definition, being a local address, you're not going through a router. So that detection or bootstrappable, once that happens, that means you can write these to the bootstrap list. So we've got this detection thing, we've got the traversal thing, and we do something with UDP to get it connection oriented. So we've got options here as well. That should be UTP, whatever that was, I can't remember. But anyway, we've got options here. So this stuff we know all gets presented as a CRUST endpoint, which is proto and then address. Now, that CRUST endpoint refers to a machine, a physical. It could be a virtual machine or a physical machine, but anyway, that's why it's a physical thing. It's a TCP stack somewhere in the world. So this endpoint that refers to this machine could be a vector of proto and addresses. Because you might have several TCP, several UDP and all the rest of it. And when the upper layer says connect, it might just pass this vector of endpoints. And we should probably not call these endpoints, because endpoints generally a socket address. We should call it something else, what these are, because that's protocol and endpoint really. Because that could be IP4 or IP6. IP6 later. But this is point with these talks is to discuss also the future. But this is what CRUST should do, I think. And then it's a case of, if we started to add another protocol, for instance, a named pipe, it already is connection oriented. We don't need that. And that's not applicable as well. But CRUST should be able to add protocols as we go along. And an name for like UDT here, we might use UTP because it's pretty good for message streams across the network, but UDT might actually be better for very high-speed local networks and high-speed data transfers. So there's no reason to imagine that this is an either or situation. We can add more and more protocols in here as we move along. So when a CRUST node starts, it's going to have a list of protocols it knows it can deal with. So a CRUST node starts and it might know that it's got TCP and UTP. So on start, it's going to have to connect at least one of each protocol. So at least one TCP and at least one UTP thing would have to be started there. But it's a peer-to-peer networking solution. And peer-to-peer, a lot of peer-to-peer stuff will be happy with just one connection each. But trust is the issue here. And this is the Starbucks attack I was talking about, where if we know there's a beacon thing, for instance, and I start a beacon node and you come to the Starbucks that I happen to be sitting in, I know that you'll connect to me. I don't know what I could do to you after that, but I know you'll connect to me. So that's probably not good. It's probably not important if you've also connected to X other nodes to begin with, and maybe you're doing a parallel get onto the network. I'll probably be able to see what you're trying to do, because I would presume you're asking everybody the same question, and even if you've encrypted it to me, I'll at least understand the initial question. That might give me something, which maybe it isn't great, but it's not a showstopper as long as we don't trust only that one connection. So CRUST seems to require one more setting. And that would be the minimum connections per protocol. I can't see why you would want to connect to 5 of them and 10 of them. I don't think there's any reason for that, because what we're saying is CRUST is almost, you shouldn't care about the protocols. CRUST is a library is going to connect for you. And in this case, you would select TCP would be your number 1 because it's more efficient than UTP would be in terms of general networking. Not all the time, but for us it certainly is at the moment. One more setting would be the minimum connection per protocol. So we might say we want that setting to be 10. We're going to bootstrap off 10 people, off at least 10 in parallel, and get the information back. And at our layer, our routing layer, we would have to make a decision on are we getting different information back from all of these and how do we cope with that. That's not CRUST's problem, it's routing's problem, but that bootstrap off a minimum number of 10. So it'll be minimum of that minimum number or bootstrap length. Obviously, if there's only 5 folk in your bootstrap, you can only go off 5 of them. That's okay. So I think that's pretty much CRUST. Actually, I can't see any more to it. I think in the background in CRUST we've got the ability to have this TCP where it's a single connection, and we should sort that so that it is a single connection. UTP already will be a single connection, and we probably want that for every protocol that we have in place. But I think that's CRUST's job. It's got to be as simple and straightforward as this. The pig in the poke, the one part that I think is requiring some investigation, Prakash, is encryption. And remember, when we're looking at CRUST, we should try and be not bothered with what routing's doing. If an upper layer's doing encryption, it's fine, it's up to it. But should CRUST offer encryption or not? So we've got TCP, and basically it's got some header info that doesn't really expose us. We don't really need to encrypt that, it's just TCP, and we've got a payload, which if the upper layer has encrypted that or not, that's great, it's up to it. So for TCP, it seems to be a quite straightforward, no, let's not encrypt it, let's pass all of this responsibility to the upper layer. For UTP or protocols similar, we've got the header, so again, doesn't expose us, not a problem. But then we've got our header, and we've got the payload. Now, whether or not that's encrypted doesn't matter. This here exposes the protocol. Now, if everybody was using UTP and their anti, it wouldn't matter. That wouldn't make any difference because it's just exposing UTP here. But if we were the only project that used UTP, then we would be exposed. So there's this part here, which is the encryption question. And when you start documenting it like this and looking at it, it kind of says that protocol needs to do something about this. This needs to hide that. Now it can't just encrypt that bit because there's a size issue. It would have to encrypt the whole thing. And my thought process here is CRUST should do encryption internally and invisible to upper layer. So CRUST would just fully encrypt that. It could leave that alone. Doesn't matter. It's up for debate. But in terms of hiding what we're doing, the upper layer can, if it wants to hide stuff, it can encrypt that, and it would also have encrypted this. But CRUST, I think, at least has to internally encrypt that whole thing, except for the UDP header. And that's That's one that definitely needs investigation. Now, in terms of doing that, it's pretty straightforward. It's pretty easy because every CRUST node is going to have a bootstrap list. It could easily write its private and public keys there and exchange the public key as its identifier. So CRUST 1 gives CRUST 2 its public key and they can start encrypting stuff. But that identity that CRUST would be using to pass keys about and clarify keys would never be exposed through the API because it just causes confusion. So that's one area I think of research, Prakash, that you would have is that encryption, because basically we're saying CRUST will use random ports, random protocols, but if we've got that exposed UTP or UDT, doesn't matter, if we've got header information which is going to give us away, then we need to look at ways of getting rid of it. And we can't use some pattern like XOR or some weird thing. It has to be actually proper encryption. Otherwise pattern matching would get used in routers and deep packet inspection and stuff. So really that encryption is the area to consider. And if we want to see how it's handled, you can actually look at that Peter Thingy guy's peer-to-peer thing out of his documentation, because they use actually libsodium to do that, and it seems to be fairly quick. So I don't think it's a huge issue to solve. I think it's relatively straightforward to solve, but it's just good to spend a little bit of time on it, being focused on that particular bit of investigation. But that's CRUST. Nice, neat library, pretty impressive library. And that's pretty much me.
Sweet.
Thanks, David.
No problem at all, Prakash.
So 1 second, let me stop this.